Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Miss Ledwell, and in this lesson, we'll talk about how to name ionic compounds containing polyatomic ions. Let's begin. To name ionic compounds with polyatomic ions, our first step is to name the positive ion first. Its name is usually the same as the name of its element, except ammonium, NH4 positive, the only polyatomic cation you might see in ionic compounds. Remember to use Roman numerals to indicate the correct charge if it is a multivalent transition metal. With the exception of ammonium, the anion will be the polyatomic ion. Find the name of the polyatomic ion by referring to a table of polyatomic ions. This will always be provided. Let's look at an example. To name this ion, we're going to name the positive ion first. So the positive ion, we look up in the periodic table if we don't remember, and it's calcium. And then we're going to name the polyatomic ion by referring to the table of common polyatomic ions. The polyatomic ion there is sulfate. Our third step is to name the compound by putting together the names of the cation and the anion. So the name of this compound is calcium sulfate. Let's look at another example. The first thing we'll do when we're presented with an ionic compound containing a polyatomic ion is to check to see if the cation is ammonium, NH4+. If it's not, we're going to find the metal on the periodic table. If the metal only has one charge listed, like lithium in this case does, the name will be the same as the element name. For example, for Li2-CO3, lithium is the name of the cation. Now we're going to refer to the table of polyatomic ions to match the formula of the polyatomic ion to its name. For Li2-CO3, we will look for CO3 in the table of polyatomic ions. And there it is. The name of this polyatomic ion is carbonate. Our last step then is to name the compound by putting together the names of the cation and the anion. So for this compound, it contains lithium and the polyatomic ion carbonate. We put those together, and the name is lithium carbonate. Next, let's look at an example where the ionic compound is a multivalent transition metal. Let's look at the compound Cu, and in brackets we have CH3COO with the subscript 2. The first step is to check to see if the cation is ammonium, NH4 positive. It's not, so then we're going to find the metal on the periodic table. Cu, copper, is a multivalent metal, meaning it can have more than one possible charges. When we look on the periodic table with ionic charges listed, we see that the common charges for copper are +2 and +1. The next thing we have to do is refer to the table of polyatomic ions to match the formula of the polyatomic ion to its name and find the charge. For Cu, bracket CH3COO with the subscript 2, we will look for CH3COO in the table. And we can see that the polyatomic ion is called acetate, and it has a charge of -1. So our next step is to balance the charges. There are two acetate ions, with each unit having a -1 charge, giving us a total of -2 for the acetate ions in the compound, because 2 times -1 each gives us -2. We know from the formula that we have one copper ion, and the common charges for copper are +2 and +1. One of which version of copper with the +2 charge or +1, would balance out the -2 charge. In this case, one copper ion with a +2 charge would make the compound neutral. One copper ion multiplied by a +2 charge is +2. We notice that +2 from copper and -2 total charge from the acetate ions adds up to 0, resulting in a neutral compound. Now we can write the name of this compound. In the last step, we determined that the charge of the copper ion is +2. Now we need to use Roman numerals to indicate this charge, so we write copper 2. The name of the entire compound then is copper 2 acetate. Now that we've gone through some examples, we're going to do some together. So pause this video and grab a pencil and some paper, or open up a blank document on your electronic device. Number your paper or document from 1 to 10. As each compound in the table on the next slide is revealed, write down what you think the name of the compound is, and then we'll go over the correct answers one by one. After you've numbered your paper or your document, resume this instructional video. Here's our first example. We have Ca and in brackets NO3 with a subscript 2. So you're going to name the cation, look up your polyatomic ion on the table of common polyatomic ions, and then put those together. And the name of this compound is calcium nitrate. Our next example is AgCH3COO. Follow the same steps, name your cation, and then look up your polyatomic ion on the periodic table. The name of this compound is silver acetate. Our next example is K3PO4. Name your cation, and then look up the polyatomic ion on the table. And this is potassium phosphate. Our next example is NaOH. Follow the same steps to name it, and we have sodium hydroxide. Our next example is Mg, and in brackets we have NO3 with a subscript 2. This is magnesium nitrate. Now our next example involves a multivalent metal. So for this one, you're going to have to do an extra step and balance the charges to figure out what version of tin this is. And we have tin 2 nitrate. For our next example, we have tin again as the cation. You will have to look up the charges on the periodic table and balance the charges to determine what Roman numerals go with tin. And again, we have tin 2 nitrate. Our next example also involves a multivalent metal, copper. So the same extra step again. After you look up copper in the periodic table, you need to balance out the charges to make the compound neutral and determine what Roman numerals go with copper. And we have copper 2 sulfite. Our next example, we have Zn3, and in brackets we have PO4 with the subscript 2. And remember that zinc only has one charge, so we don't have to do that extra step of balancing out the ions to make a neutral compound. There will be no Roman numeral attached to zinc. So we have zinc phosphate. And our last example starts with nickel, which is a multivalent transition metal, so you will have to balance out the charges in this case. And we have nickel 3 carbonate. Now it's time to continue to the next video, where we will explore writing formulas for ionic compounds containing polyatomic ions.